Hi guys, welcome to my channel. My name is Hulabula. I'll talk a bit about my experience as a noob in Houdini. I just walked through a tutorial called Applied Houdini Rigids Volume 2 version 2, and I'll have a link in the description. I don't work in VFX or anything, but I do it in my free time. I come from a programming background, so I think I got maybe a bit for free there in talks about data flows and stuff in Houdini. But yeah, I just wanted to share what I've done in this tutorial because I think it's really cool. So yeah, welcome to Houdini. You see, I got my house here. In the tutorial, we blow up this house, basically, and we do a simulation that fractures this whole building. He starts with this procedural building in like the first hour. So I got a node here. Houdini's node based. I won't go through how Houdini works. So this control node, I got my building size here. So I can middle mouse drag and extend the building. So this is like a really basic procedural building, but I think it's really cool because the front facing sides or walls here with the windows, that is glass, a glass material, only happens on this side. So inside, you can see here that it's only there is no walls inside. I don't know why, but I guess I can add that if I wanted to. And then I can regenerate my fracture. So I added a button here. Yeah, so that's basically the procedural building. So the procedural building also applies materials. I think I can go in here. Yeah, so this is the procedural building right here. So you can see like the concrete floor. We got the concrete column. This is without the materials. Wall small, wall big. And we got the wall front with the booleans cut out from the box windows here. It's a really cool workflow that you can add more windows or whatever and just cut them out, color them and merge them with the windows that goes from the same box in the beginning, but you make them tinier and apply them and make windows and color them and so on. So yeah, it's a really different from Maya, but really cool, I think, this kind of workflow. I think you can do most or maybe everything in Bifrost, but I haven't really gotten into Bifrost because whenever I Google Bifrost versus Houdini, the answer is always Houdini is king. Or at least that's what I've gotten from Reddit and so on. All right. So yeah, that's the layout and like the procedural building. You also got like a sim version. So we connected these two attributes to a lot of like paths in the simulation, and because we cache a lot of files on disk. So whenever we wanted to change the simulation or like do another version, I can just do sim version 1 here, and it will create different folders and so on the disk. So that's really handy, I guess, for workflow to have like a control panel that you set up yourself, so you can edit the parameter interface here and add more like integers and whatever toggles and stuff and do anything you want. I think you can connect like Python to this as well, or yeah, you probably can. So yeah. Then you have the piece version. We connected this to like a power to 3 in the fracture. So it's basically how much fracture each of the different parts get. If we go into the fractures node here, we show that. So here we have all the different pieces fractured. So I can enter this and just go into the concrete wall maybe. Yeah, so here you see the RBD fracture. Let me hide the other stuff. Okay, here. So if I do like piece version 1, you can see that you just have to think a bit. Yeah, but you can see that it's clearly less detail here, and piece version 1 or 0, even less detail. So I had it at 3, and this is just for one wall. So I can make it an exploded view here, where you can show basically how the different parts fit together. So that's really cool. And we cache this with this cache node and we do some packing and instancing for memory management, and like this piece is copied then to every other wall. So it's like the same cracks in each wall, but we flip it around, turn it 90, not 90 degrees, but 180 degrees to make these cracks non-repetitive as much as we can, but still having the memory footprint of one object. So it's very memory efficient, this tutorial and this approach to destroying buildings or destroying whatever, I guess. Yeah, so we cache it and we unpack that again. So here you can see the sim version and the piece version. So we do some magic expressions here where we connect the channel to SVR, which is like the sim version. You can see that if I go to 2 or 1, you change this path. So that's really cool. And this method we have in a lot of nodes, in a lot of caches in different places in the whole project. So we all control that from this main control node in the top level. So that's, yeah, really cool. Then we got this material where we apply some basic materials. He didn't go through a lot of material design or whatever. The main focus was on the RBD explosion things. But you can see here that we have a darker material on the outside and a lighter material on the inside. Pretty cool concrete. So the same things for all the concrete stuff, I guess. A little bit different for the floor. I think it was more subdivided, but yeah. Then the glass had a totally different vibe to it, where we used RBD glass. I think it was a template, yeah, material type. So you have different types and you can use custom as well. I have no idea how to do that though, but yeah, it's really cool, I think. Basically, after we did all these fractures one time for each object, you can then construct them back again. Let me see if I can zoom out or if my computer is dying. Oh, wow. Okay. Maybe it only has memory to do these parts. As I said, I was on another computer that has 128 gigabytes of RAM before now. And we're back, I think. Yeah, I only have 32 gigabytes of RAM on this, but I think it was my beautiful, beautiful graphics card that didn't have the time of its life just now. Yeah, so maybe you can see, but it's the same window, but like flipped over. So you save a lot of memory. Yeah, so it's the same fractured pieces flipped over and everything on every part. So you can have more parts basically and bigger houses and bigger simulations. But your CPU still has to calculate every piece. So the simulations will go slower, obviously. But if you don't have a lot of RAM, this is a really good approach. And I think this approach would be really good for games in general, but I guess they are doing some game magic like Unreal Chaos or yeah. In the tutorial, he goes through how to make custom constraints between the parts. So that's what keeps all the parts together. You can see if I can show you guys without it crashing. One really good thing about Houdini in general is this information bar that tells you whatever it's calculating or doing when it seems to have freezed. As you can see, my computer is crying right now. This is just one frame for the calculation, so I don't really know if it's gonna succeed. Segmentation fault. Perfect. Go to sleep, Houdini. Okay, let me take it down to like piece version 0 so my computer actually can handle it. So now I'm caching the fractures of all the single pieces. So that should be pretty fast even on this computer. Dun 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 dun. Famous last words. Yeah, so here you can see more clearly the repetition in like the glass. And here you can see more clearly. So it's a really cool workflow because in the simulation, you don't really see it because everything is getting destroyed. And it's a much higher detail than this. So we basically create constraints here with a glue attribute. And it goes through how to make these custom ones as well. And we can cluster them. This was really cool. You can cluster them, yeah, here with the size. So if we decrease the size, make the size larger, you get larger clusters that are stronger together. It's like a bigger piece that has pieces. And then you got connections between clusters as well. And you got controls for that. So yeah, it's a really, really cool system. And you can, like everything is customizable. So it's, yeah, really dope. And here you got all the glass. And here you can clearly see that it's repetitive. So here you got the constraints for them. Cool. And then you combine all the constraints to one big constraint mesh. And let me show you one big thing of Houdini. I think I can go into the technical. Here you got the geometry spreadsheet. So this is a really big part of Houdini. So everywhere in these flows or these lines, you got different properties on the primitives or the points, primitives, the faces. Yeah, so you got like different colors, you got density, and everywhere. If you middle mouse on any node, you can see different attributes. So this is really cool. Along the tutorial, we set a lot of different properties with often with these primitive wrangled nodes. So I set here an integer is external if the strength is less than this threshold. And it basically creates this slider. So it's really a really cool system. Yeah, so you can set different attributes basically and do different stuff with that. So this name, for example, here you can see the constraint name, if it's external or not, the type of material as well. Yeah, so that's really cool. When we start to simulate, the bottom is simulated against the ground. So we make these pieces sleeping in the beginning. The building is basically more stable in the beginning of the simulation until the explosion happens. And then we break a lot of constraints and stuff starts to fall apart naturally, including like the bottom. Cool. And then we got the last, or not the last, but the main simulation. So here you got like the force, and that is basically a big sphere in this area. Here somewhere, frame 3. There we go. This is the force that happens only on frame 3. So every constraint inside this is basically broken. And also a force is applied that we set. So that's pretty cool. And we got some gravity. We got some air drag for all the pieces. It's also not ignoring the mass of all the pieces. Yeah, and you got settings for the solver. I haven't gone through this. It's so cool though. So basically we cache out the simulation. But the simulation is basically only these points. So that's really, really cool. And then we cache the points, and you see we got the same sim version, whatever, P0, etc. And then we reconnect like the proxy geometry or the high-res geometry to those pieces. So that's really cool. But then we get into the render. If we go into the tasks menu here, we get into the coolest part, I think. I saw this a couple of years ago, and I thought it was really cool. And I don't really do VFX, so. But yeah, so here we got a topnet. So this is like Houdini's new or pretty new workflow with like pipeline tools. So here we got a wedge. I only got one here, which is the glue strength cluster. Attribute. So with this, we can create multiple simulations at once. So this attribute, we can create wedge count 3 maybe. It's a float, and we can do a range from 800 to 3000, as I've done on the screen right now. So it changes this. So if I recook it, you see that we got 3 different nodes, and I can click any one of them, and then I set it to like, now it's 3000, now it's 800, and now it's something in the middle. And we can also do like a value list. Yeah, so it's really cool. And we can do multiple wedges as well for any parameter in Houdini. So that's, I think at least, I'm no expert. Yeah, so then we go through and we do a render. We do a video, I think. Let me check. We do, the render. We save it as a PNG from the viewport. So that's cool. Then we add overlay text, and we save those files in a different folder. We wait for them frame by frame because we want each frame to be done. Then we got partition by frame. I don't really remember what this was. I think it's waiting for each frame. So basically the overlay text frame 11, for example, and the render 11. Yeah, something like that. Then we got the image magic, which is a separate program. Really cool. So we combine all of these images to one video, and then we encode this video, something like that. So it's really cool. And I wrote a separate Python processor here only to try it out. So This just checks for the names or like the attributes here and combines them into like the lowest and the highest number in this wedge and combines them into a string. So that was just for me to create the names of this my string. So this my string would be like 800 to 2000 here. Yeah, so that was just for fun to try to learn this PDG workflow. When it runs, it looks really dope, but it's on the wrong computer now. Again, sorry. Yeah, and then we get the video. So with this, we can take better decisions about the variables in Houdini and the simulation properties and whatever. So that's really cool. We don't have to sit and click. We can just batch render a bunch of stuff, hopefully on like a different computer or a server or something that I don't have at the moment. But yeah, it's really, really cool stuff. And then basically we rendered it out with some materials, really basic materials. I tried Karma as well. I didn't really get friends with it, so I haven't tried it a bunch. But yeah, we did a render with motion blur, not high settings at all. So you can see a lot of noise in the windows and such, but it's just for testing. It still took like 2 hours to render all the frames, 120 frames. He also goes through how to make the windows not look broken in the beginning of the render. I didn't bother, but you can do that as well. And he also goes through how to render with Karma later in the tutorial. Didn't watch that, but maybe I will another day. Yeah, so thank you for watching. Let me know what you think in the comments below. Did you like this type of content? What application are you using for building destruction and particle simulation and water and the FX and stuff? Is it the Houdini, Blender, something else? Let me know. All right, have a great day. Bye.